Hello, I'm Kristin Stockton. I'm a master's student at West Virginia University, and I will be discussing my thesis work on wastewater outfall as a limiting factor to freshwater mussel reintroduction and recolonization. This work was done in partnership with the West Virginia University Co-op Unit and the West Virginia Division of Natural Resources. Wastewater treatment plant outfall is an emerging concern within the freshwater mussel community. So whether that be in a stream that has an existing mussel population or in extirpated streams. So it's thought that this wastewater treatment outfall and the chemicals that it may contain could be a barrier to freshwater mussel reintroduction, recolonization, and just reproduction in existing populations. So anywhere that you have people, you're going to have these wastewater treatment facilities, and as the name indicates, the water coming out is treated. However, that treatment process doesn't remove all of the pollutants. And so you can still have ammonia, chlorine, copper, industrial chemicals, pharmaceutical and personal care products. And so that comes down to like the estrogen and birth control, the chemicals that are in antidepressants, any sort of cosmetic product. And so anything that you are putting in your body or down your drain ultimately can come back out in this outfall. And all of the impacts to freshwater mussels from that aren't fully known. Research does show that mussels are more sensitive to a lot of these contaminants than other aquatic organisms, specifically the ones that have been used to kind of define the EPA's permitting for these outfall sites. So specifically referring to Wang et al., their study showed that freshwater mussels, particularly juveniles and glaucidia, are very sensitive to a lot of the components that can be in this discharge, more so than the species that were being used to refine those discharge thresholds. And fortunately, the EPA has since revised them and included mussels in their toxicity testing, but there's still kind of a gray area in terms of what magnitude of outfall can affect freshwater mussels, and particularly in a field setting and concerning juvenile mussels. These are my main study questions. Ultimately, I wanted to determine if proximity to the wastewater treatment outfall impacts juvenile mussel survival and growth, and identify any other limitations, and then potentially in the future establish a monitoring and reintroduction site on my study creek, Opequon Creek. My primary study stream was Opequon Creek, which is a candidate for reintroduction by the West Virginia Division of Natural Resources. So there have been surveys completed on Opequon Creek dating back to approximately 1990, and no live mussels have been seen in the stream. However, there's a lot of dead shell, which indicates that at some point there was a stream-wide mussel kill. The fish population seems to be relatively healthy, although there have been historic fish kills as well. And this is considered an impaired stream based on fecal coliform presence and benthic macroinvertebrate population. Opequon Creek is also seeing a lot of suburban growth and conversion of agriculture over to housing developments, and with that comes more wastewater treatment plants to deal with that growing population. My control stream was Back Creek, which is considered a high-quality recreation stream. It has a robust friends group and a highly forested network of farm easements. There are known mussel populations in Back Creek. This is a map showing the land cover type and location of wastewater treatment plants on Opequon Creek and Back Creek. So Opequon is the creek on the right that has a cluster of wastewater treatment plants around it. You can also see there's significant suburban growth around the Martinsburg area and a lot of agricultural land. And while there is some riparian corridor compared to Back Creek on the left, there definitely is a significantly lower amount on Opequon Creek. Additionally, you'll notice that Back Creek has no wastewater treatment plants and thus no outfall. I selected 8 sites on Opequon Creek and 4 sites on Back Creek. Four of the sites on Opequon Creek are paired, so that there is a site above and a site below a wastewater treatment facility. I did my best to spread sites throughout as much of the stream as possible. Opequon Creek 1, the highest up in the headwaters, is above any known sources of wastewater treatment outfall. And Opequon Creek 2 occurs directly above the first outfall. I placed 4 Barnhart silos and a hobo conductivity and temperature logger at each of my 12 sites. Each of those 4 silos contained 15 juvenile lampsless cardium mussels per silo. The mussels were left in the stream from May 22nd to November 16th of 2019 for a total 177-day exposure. 2 times each month, I took basic water quality measurements using a YSI meter, and then once a month, I collected water samples for processing at a lab for ammonia, chloride, nitrate, mercury, and copper. Also, the mussels were measured once per month, and any dead mussels were removed. There's still some more in-depth analyses that I'd like to do, but for the time being, I can show my current results. So looking at the percentage of live mussels at each site at the end of the study, you can see that Back Creek did tend to have a higher survival rate than Opequon Creek. Opequon Creek actually had 2 sites that had total loss of mussels. And you can see the highest percentage of live mussels was at Back Creek 12, which had 63% survival. If we look at growth, while there isn't as obvious of a difference between Opequon Creek and Back Creek did tend to trend a little bit higher in terms of growth, although none of the mussels grew significantly over the 6 months that they were out in either stream. And obviously this figure doesn't account for sites where all of the mussels died. The conductivity on Opequon Creek was about twice that of Back Creek on average. I was anticipating seeing the highest conductivity levels at the 2 sites that were directly below wastewater outfall, indicated in the red. And I was kind of surprised that Back Creek 3 did not show up as higher, because that was the area where it seemed like the wastewater outfall was most prominent, and sometimes on the YSI we clocked up to 3,000 microsiemens per centimeter. However, this figure is looking at the average conductivity per month at each site, and so in the next figure you'll see that it's a little bit more evident that the wastewater treatment outfall is contributing to the high conductivity level. So this figure looks more at the individual data points taken every hour by the hobo logger. And you can see that on Opequon Creek 3, that while the average conductivity is not the highest for that site, that it did have the highest total conductivity for any individual recording. And while not as substantial as Opequon Creek 3, Opequon Creek 8, the other site that was directly below wastewater outfall, also has a really broad range of values for conduct. I suspected that the temperature would be higher below the wastewater treatment outfall sites. However, you can see from this graph that Back Creek actually tended to have higher temperatures than Opequon overall. And there is one exception. If you look at October and November, you'll see the dark copper bar that represents Opequon Creek 3. That site did tend to have higher temperatures. Also of note, in the samples that we sent to the lab, chloride was extremely high at Opequon Creek 3. So based on Dr. Wang's work, the chloride here exceeds the EC50 for toxicity to mussels closely related to the lampsless cardium that were in the silos. So while chloride was not nearly as harmful to mussels as mercury or copper or ammonia, in this case, the chloride level is extremely high. and could potentially be impactful, particularly the juvenile mussels. And that high reading is coming from Opequon Creek 3 once again. So going back to our original questions, should we reintroduce mussels to Opequon Creek? At this point, I think that would be premature. While adult mussels could potentially survive, I think it would be highly unlikely that reproduction would be successful. Does wastewater outfall impact growth and survival of juvenile mussels? While I do want to do further analyses, I think that my tentative answer is yes. I think that it's particularly impactful when you're dealing with a smaller stream. So on Opequon Creek, the two sites that were directly downstream of wastewater outfall were Opequon Creek 3 and Opequon Creek 8. Opequon Creek 3 is where we saw the most pronounced impacts, and it's about a third of the width of Opequon Creek 8. And so Opequon Creek 8 is closest to the mouth. It's a very swift and deep section of stream. It's much wider than Opequon Creek 3. And so I'm not surprised that Opequon Creek 3 saw much higher readings from the wastewater outfall discharge. And I think that's something to consider when permitting these outfalls is the order of the stream, the volume, and it could be much more harmful to mussels that are in these smaller area sections of stream than those that are closer to the mouth or in swifter flowing, deeper water. And then what are other potential factors impacting mussel survival and growth in Opequon Creek? I definitely think that the conductivity and the presence of substantial amounts of chloride definitely could be a limiting factor to reintroduction. But other than that, so there are a lot of high water events on Opequon Creek, and I think that the flashiness of those events will only continue to increase with the addition of more impervious surface and potentially with climate change. And what those flashy events are doing is creating a lot of kind of transitional habitat within Opequon Creek. There are a lot of loose, fine sediments. There's not a lot of interstitial space. And so I think ultimately suitable habitat is probably a limiting factor to both natural recolonization and the success of reintroduction efforts. Thank you so much for listening. If you have any questions, please post them in the comments. And thank you to the Freshwater Mollusk Conservation Society for the opportunity to speak.